Myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in this series of lectures, I am going to deliver my lecture on the optical communication. The topic which I am going to cover during this lecture are types of rays, then acceptance angle for skew rays, electromagnetic mode theory for optical propagation, that is the electromagnetic waves. As far as rays are concerned, rays are plays a very important role while we are discussing about the optical communication, because rays are actually the information carrier during the optical communication. In the rays itself, we used to provide the information which we have to transfer from transmitter end to the receiver end. So, the study of rays plays a very important role when we are studying the optical communication. So, here in this particular slide, I am going to discuss with you about the different types of rays. The first rays is the axial rays. The first ray is the axial ray, the second one is the meridional, the third one is the skew rays. These are the three important type of rays with which we come across when we are studying the optical communication. So, first one, the axial rays. The axial rays is what? As the name indicate, in the axial rays, the name is axial, that means axis. So, in this rays we have to something to do with the axis. So, in this particular type of ray, that is axial ray, the ray travel along the axis of the fiber and stays at the axis all the time. So, what the importance of this particular ray? In this particular ray remains inside the axis of the along the axis of the fiber, that is, it travels parallel to the axis of the fiber and stays along with it throughout the transmission process. It does not move here or there during the whole transmission process. Now comes the second one, that is the meridional rays. Till now, whatever we have studied in the previous lectures of optical communication, where we have calculated the numerical aperture, acceptance angle, etc., we are discussing basically the meridional rays. So, what is the significance of meridional ray? The meridional ray enters the core and passes through its axis. That means, what is the difference between the axial and the meridional rays? Axial ray travels parallel to the axis of the fiber, but meridional ray passes through the axis of the fiber. So, there is a difference. First one, if we consider this as the axis of the fiber, axial ray travel parallel, that means we consider this as a axial. But when we talk about the meridional ray crosses this axis of fiber. So, this is the one of the most important difference between the meridional ray and the axial ray. Now, we are moving towards the third one, that is the skew rays. Skew rays is also one of the most important type of rays through which we come across when we talk about the optical communication. But again, the difference, skew rays does not pass through the center and through the axis of the fiber. When we are saying that skew rays does not pass through the center, that means it does not pass through the axis of the fiber. It reflects from the core cladding boundaries. It itself reflects from the core cladding boundary and again bounces around the outside of the core and remains bouncing outside of the core. It does not enter inside the core after that and does not cross the fiber axis of the fiber. What shape is take? It takes a shape of a spiral. It takes the spiral shape when it is moving toward. So, what is the difference? Does not cross the fiber axis. So, the basic difference when we talk about the different type of rays are follows. Axial ray travels parallel to the axis of the fiber. Meridional rays passes through the axis of the fiber. Skew rays does not passes through the axis of the fiber. It reflects from the core cladding interface and bounces outside the core and follows the spiral path while traveling. So, these are the three important type of rays through which we come across when we are talking about the optical communication, and here is the basic difference between these three. Let us look at the figure representing the movement. Here comes the first, we are talking about the axial rays. Axial ray, of course, this is the axis of the fiber. This dotted line is the axis of the fiber and the ray which is travelling parallel to the axis of the fiber, that is our axial ray. And we can easily say that during the axial ray process only the losses will be minimum, but this ray is very travels inside the optical fiber in very less number. Now comes the meridional ray. Meridional ray crosses the fiber axis, and you are seeing in this particular figure, it is travelling inside the core and it is crossing the fiber axis, or even can easily see there also fiber axis exists this way or in this way. If it will exist this way also, it will cross this way, and this is the dotted line is the fiber axis, and the meridional ray is basically crossing the fiber axis. And now comes the skew rays. Skew rays, are you able to see in this picture that it is following the zigzag shape? It is following the zigzag shape. It undergoes the multiple reflection before coming out of the fiber. The reflection, it undergoes multiple reflections before coming out of the fiber, and this reflections plays a very important and significant role when we are talking about the advantage of this particular skew rays. And skew rays has got one of the most important advantage over the meridional rays. One of the most important advantage of the skew rays over the meridional ray is that in the skew rays our acceptance angle or numerical aperture is higher than the skew rays. Again I am repeating, in the skew rays the numerical aperture is higher than in the meridional ray. And now comes the again I am asking from you कि आपको याद होगा कि जब हम when we are talking about the numerical aperture in the previous lectures, I have told you कि अगर numerical aperture की value जितनी ज़्यादा होगी, हमारे acceptance optical fibers का acceptance signal का उतना ज़्यादा होगा. Information of course अगर rays की acceptance ज़्यादा होगी तो of course information carrying capacity भी आपकी बढ़ेगी. तो numerical aperture is directly proportional to the ऑप्टिकल सिग्नल कैरिंग कैपेसिटी। तो हम हर एक केस में चाहते हैं कि न्यूमेरिकल अपर्चर की वैल्यू ज़्यादा हो। न्यूमेरिकल अपर्चर की वैल्यू जितनी ज़्यादा होगी उतना हमारे लिए इंफॉर्मेशन सेंड करना फ्रॉम द ट्रांसमीटर एंड टू रिसीवर एंड ईजी होगा। तो न्यूमेरिकल अपर्चर प्लेज अ वेरी इंपॉर्टेंट रोल when we are talking about the optical communication. So if in any rays, in whatever rays numerical aperture value is greater, that ray is of course much more significant than the other one. So in this particular rays, that is between the meridional and the skew rays has got a maximum numerical aperture as compared to the meridional ray, and how we will see in the next slide. The second important difference which arises between the skew rays and the meridional rays is that आपकी number of reflections before coming out of the fiber, हमने ये कह रहे हैं कि ये जो reflections हो रही हैं, यहाँ से रे यहाँ गया, again reflection, जब 2 पे पहुँचा again reflection, जब 3 पे पहुँचा again reflection, and then 5 पे पहुँचा again reflection. तो ये multiple reflections हो रही हैं inside the, और आप स्क्यू रेज में देख रहे हो बट उतनी ज़्यादा रिफ्लेक्शंस कम है एज कंपेयर टू स्क्यू रेज। तो जितनी ज़्यादा रिफ्लेक्शंस हो रही हैं आपके स्क्यू रेज के केस में, उतना ज़्यादा स्मूथनिंग प्रोसेस हो रहा है। स्मूथनिंग, सिग्नल की स्मूथनिंग। तो जितनी ज़्यादा सिग्नल की स्मूथनिंग होगी, आपके पास जो आउटपुट में सिग्नल मिलेगा वो ज़्यादा रिफाइंड केस मिलेगा ऑफ कोर्स। तो दिस आर द टू some of the major differences between the skew rays and the meridional ray, and it is often asked from you what is the difference between, explain some difference between the skew rays and the meridional ray. So you can write out there. Or the third one more difference between the two, कि आपके कितना डिस्टेंस ट्रैवल करेगा स्क्यू रेज, वो डिपेंडेंट होता है कितने नंबर ऑफ रिफ्लेक्शंस इसमें हो रहे हैं। तो डिस्टेंस ट्रैवल्ड is directly proportional to the number of reflections. Distance travel, or we can say at what time it will come out of the fiber, both are the same. तो ये भी लिख सकते हैं आप, और at what time it comes out from fiber. So it all depends upon the number of reflection a skew rays undergoes while traveling inside the optic. और मेरिडोनियल रेज के बारे में तो डिटेल्स हमने प्रीवियस लेक्चर्स में डिस्कस किया हुआ है, और ऑफ कोर्स वी हैव डिस्कस द differences between the two, so that you can easily write the differences between the skew rays and the meridional rays. Now in the next lecture topic, in the next slide, I am going to discuss about the numerical aperture. Numerical aperture of course कितना rays accept करता है, that is proportional to the acceptance property of the optical fiber. Numerical aperture is directly proportional to the acceptance property of the optical fiber. तो in the next slide हम ये देखेंगे क्यों आपका skew rays में सिग्नल की एक्सेप्टेंस प्रॉपर्टी, एक्सेप्टेंस एंगल, और वी कैन से न्यूमेरिकल अपर्चर क्यों ज़्यादा होती है एज कंपेयर टू मेरिडोनियल रेज. नाउ here is the one picture representing about the ray diagram inside the optical fiber due to skew rays. अब इसमें सबसे इम्पॉर्टेंट और वो है आपका कोर एक्सिस, कोर एंड द क्लैडिंग. आपका यहाँ पे आता है, देन इट विल मूव इनसाइड द कोर, दैट मीन्स एयर से इनसाइड द क्लैडिंग एंड देन इनसाइड द कोर. और ये एक रिफ्लेक्शन दिखाई हुई है, बहुत ज़्यादा रिफ्लेक्शन नहीं दिखाई हुई है. बट व्हेन वी आर टॉकिंग ये रिफ्लेक्शंस मल्टीपल रिफ्लेक्शंस होती है. मल्टीपल रिफ्लेक्शंस एग्जिस्ट इन द केस ऑफ स्क्यू रेज. ये रिफ्लेक्शन जो होता है that is always equal to 2 gamma. This reflection is always equal to 2 gamma. If we divide this 2 gamma, though this will be gamma and this will be gamma. So gamma is the angle of reflection for skew rays within the fiber, and this gamma plays a very important role. कि जितनी ज़्यादा रिफ्लेक्शन उतनी ज़्यादा स्मूथनिंग, और that will affect our numerical aperture. The acceptance angle, or you can say the numerical aperture within the skew rays is given by sine inverse under root n1 square minus n2 square. As known to you, n1 is the refractive index of core, n2 is the refractive index of cladding. And for total internal reflection, which is the standard or most important phenomenon for the total internal reflection, which are responsible for the optical communication, for that to occur, n1 should always be greater than n2. This is the most important condition for total internal reflection to be occur. For total internal reflection. Internal reflection. So, these conditions are the general condition about which already known to you and already discussed in the previous lecture. So, and under root n1 square minus n2 square is equal to our NA, sine inverse NA upon cos gamma. So, if acceptance angle is equal to sine inverse under root n1 square minus n2 square divided by cos gamma, if under root n1 square minus n2 square is equal to our numerical aperture, that is NA, so we can easily say acceptance angle for skew rays should be given by sine inverse NA upon cos gamma. And now cos gamma की value in general cases during the propagation, cos gamma की value is less than 1. अगर ये less than 1 है, so of course acceptance angle की value ज़्यादा होगी skew rays में as compared to meridional ray. Of course इसको भी हम थोड़ा देख लें. Now for meridional rays, our acceptance angle is given by sine inverse n1 square minus n2 square, or we can say sine inverse NA. ये हमारे मेरिडोनियल रे का एक्सप्रेशन है फॉर द एक्सेप्टेंस एंगल, और स्क्यू रेज एज गिवन दिस. सो अगर हम कह रहे हैं कि कॉस गामा की वैल्यू 1 से कम है during the propagation of the skew rays inside the optical fiber, if we are saying that its value is less than 1, then what does it indicate? कि of course ये जो value है आपकी that should be less than sine inverse n1 square minus n2 square से ये value कम होगी. अगर ये value कम होगी, that means acceptance angle of meridional ray is we are saying that इसकी वैल्यू cos गामा की वैल्यू कम है, that means that should be greater than this one. अगर acceptance angle अब skew rays का ज़्यादा है as compared to the meridional ray, so of course ये आपका हम कह सकते हैं कि it's the advantage of skew rays over the meridional ray. Now just have a look at the one of the numerical. What the question says, an optical fiber in air has a Na of, that is numerical aperture of 0.4, and now compare the acceptance angle for meridional rays with that of the skew rays, which change direction by 100 degree. That means first I am going through the meridional rays. Acceptance angle is given by sin inverse Na. So, Na value is given as 0.4 here. So, sin inverse 0.4 should be after calculation we get as 23.6 degree. Now, for skew rays, acceptance angle is given as sin inverse under root n1 square minus n2 square upon cos gamma. Already known to you that under root n1 square minus n2 square should be equal to Na. Na upon cos gamma. But in the questions reflection जो है वो 100 degree का है. That means if we are representing the skew rays by this way, this 2 and gamma should be equal to 100 degree. This implies gamma should be equal to 50 degree. So, sin inverse Na is 0.4 upon gamma is 50. Now, this will be equal to 38.5 degree. So, we can easily say that acceptance angle of a skew rays is higher than that of the meridional ray. Now we are going to discuss about the electromagnetic mode theory for the optical propagation. Before going through that, we have to come across the electromagnetic wave equations. So, before studying the electromagnetic mode theory of optical communication, we will discuss the electromagnetic wave equations. And the basis of electromagnetic wave equation is of course our Maxwell equation. So, Maxwell gave us the 4 equations, and here I am going to discuss it for the free space, a general condition. We are not considering the conducting case, we are considering here the free space case. So, in the free space, what should be the equations? So हमें पता है कि 2 कर्ल इक्वेशंस होती हैं, 2 डाइवर्जेंस इक्वेशन होती हैं. तो फर्स्ट डाइवर्जेंस कर्ल इक्वेशन इज डेल क्रॉस E शुड बी इक्वल टू minus of del B upon del T. All are the vector 1 here. So, do not be get confused, all are the vector 1. Del cross E should be equal to minus del B upon del T, del cross H should be equal to del D upon del T, del D is equal to 0, del B is equal to 0, and all this equation for the free space I am again repeating. And as we know that D is equal to epsilon E, B is equal to mu H. Epsilon is our permittivity, and mu is our permeability. And these are the 2 properties of a material which we are using for the propagation purpose. So, and epsilon is always given by epsilon naught upon into epsilon r. So, what is epsilon naught? Epsilon naught is called as the absolute permittivity, and what should be the value of absolute permittivity? The permittivity of a air or vacuum is called as the absolute permittivity, and relative permittivity is the permittivity of the material which we are considering for propagation, mu naught into mu r. Of again absolute permeability, which is the permeability of a free space or vacuum, and relative permeability, that is the of the material. So it can also be written as is equal to 0 that is del dot E should be equal to 0, del dot H should be equal to 0. Now, when we take the curl of the curl equation, what we are getting? We are getting this 2 1. When we take the curl of the equation, we are getting this one. So, how we are getting this? So, using this vector identity, we can write del dot E minus del square E, and we know that del dot E is, as per the last slide, del dot E should be equal to 0. So, we are getting that in the place of this, we can write this one with a minus sign. With a minus sign, del dot cross del cross. Similarly, for this one, we are getting this. So, we are getting the general equation for the wave propagation. This is the general wave equation in the terms of E and H field. And when we compared it with a general equation of a wave, this Vp, that a phase equation, phase velocity, when we compare the equation in the terms of E and H field, what we get in the last slide, we are getting the phase velocity as this. In the when we write the general equation in the terms of this, when we write the equation as this, we are getting our phase velocity as this, which can be used for each and every electromagnetic wave propagation. And this is the general expression in the terms of Cartesian coordinate, and this is the terms of cylindrical coordinate. Wave equation solution, when we solve that equation which we are getting in the last slide, इसको जब हम solve करेंगे हमें wave equation इस तरह से मिलेगा, where k is our propagation constant, which is denoted by this value 2 pi upon lambda, and r is the radial coordinate जहाँ पे आप observe कर रहे हो changes, that is our r. So ये हमारा important है, और वे propagation constant हमेशा value remember करना है. Sometime it is also represented by beta, sometime it is represented by gamma and all, but value remains the same of a propagation constant, that is the 2 pi upon lambda. So here comes the end of the today's lecture. In the upcoming lecture, we will discuss about the mainly on the optical propagation. Optical propagation में कैसे हमारा electromagnetic mode theory work करता है, उस पर हम discuss करेंगे. Thank you for today.